Hi, my name is Kelsey Owens, and this is my project on Iceland and the geologic history about it. So Iceland's location and formation, some geologic processes that come to mind when thinking about Iceland include plate tectonics, seafloor spreading, hotspots, and especially volcanoes. Many do wonder how Iceland came about. A so-called hotspot, the Iceland plume, is located near the mid-Atlantic ridge in North Atlantic and is believed to have caused the formation itself. There's a lot of mineral composition, and that is mostly basalt, and basalt is fine-grained igneous rock. It's also the most common volcanic type of rock on Earth. Basalt is the key component when it comes to oceanic crust, as well as the principal volcanic rock in many mid-oceanic islands, including Iceland. I did some research on fun facts about Iceland because I personally did not know a lot about it. And Iceland is considered a fairly young country. It was settled sometime in the 800s by the Vikings, surprisingly. Another geologic feature of Iceland is glaciers. They're responsible for carving out everything in Iceland that hasn't been shaped from the magma from volcanoes and earthquakes. Iceland is actually very, very eco-friendly. The whole country is essentially alive with volcanic activity. The nation harnesses hydro and geothermal energy that powers more than 80% of the country, which I think is amazing. Some more fun facts is there is very little crime there, and I found out the police often don't even carry guns, which I don't think I'd feel too safe about if that was the case here. Also, Iceland is located very close to the Arctic Circle, so they experience long winter nights and summer days, almost 24 hours of darkness in December, and nearly 24 hours of daylight in June. I could not imagine that. I looked up a geologic timeline relating to Iceland, and I found out about 100 million years ago, the volcanic plume under Iceland was formed. Because of this, the mid-Atlantic ridge and ocean was being formed. About 70 million years ago, Greenland was southeast of where Iceland is now. About 70 to 60 million years ago, Greenland was moving slowly towards the northwest and drifted over the hotspot under Iceland. About 55 million years ago, massive amounts of volcanic activity occurred when Greenland drifted away from the hotspot under Iceland. Continuous amounts of basalt lava were formed for millions of years. About 30 to 20 million years ago, the sea managed to cut off the land bridge between Iceland and Greenland, which led to an island formation, which is now what Iceland is referred to. 16.5 million years ago, the oldest rock in Iceland was formed in eruption in a volcano. 15 to 3 million years ago, endless eruptions were what built Iceland. And also, 11 million years ago, huge eruptions formed shield volcanoes in northeast Iceland. Wow. About 2,000 years ago, the last eruption of the central volcano Hengil occurred. And then around, I think it was like 875 AD was when human settlement began. Okay, so there is a lot of geologic mechanisms when it comes to Iceland. I showed a diagram, and the photo basically shows how the different geological mechanisms have an effect on Iceland, including mid-ocean ridges, divergent plate boundaries, and like earthquakes and magma and all of that. So this is what the diagram is showing. And another feature that they have there are geysers, which I actually did not know much about at all until researching. And the other things that they need to form is a heat source, a constant water supply, and an underground plumbing system. And so basically this diagram right here is showing at the top as the water is coming down, flowing down into the ground, and then basically at the bottom is where all the heat is, and that's what heats up the water, which then causes it to boil, and all the pressure from the boiling water pushes the water up and back through the ground and then out, and that's what forms a geyser. And the only way that it can basically stop is if it runs out of water. The current situation of Iceland is there's a lot of volcanoes and earthquakes, which are very, very common there. There's 3 rift zones throughout Iceland that have formed recently. This is due to the spreading of the mid-Atlantic ridge. And then this diagram below, the blue is showing ice caps, and then the red is active rift zones, which include the northern rift zone, the eastern rift zone, and the western rift zone. And then the yellow is volcanic activity, and gray is just abandoned rift zones. The future of Iceland, the climate change is causing Iceland to rise, actually, and ice caps are rebounding from Earth at a rate of 1.4 inches per year, and it's causing land to be free. The downside of this is the extra uplift is actually causing volcanic activity to increase. So based on these facts, we can predict that in the future, Iceland will clearly rise, and that will cause a huge, huge increase in volcanic activity, which is not good at all. So that is my presentation, and I hope you enjoyed. Thank you.